Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So this person's at Ashcook at 2017. So they're going to have missed this train here, and they're going to have missed this train here. So those are off, but they will be in time for this train here. And we're looking for the time it hits rise down. So it will get to flute at 20:52, and then rise down will be at 21:24. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. We're going to start just by copying out the question. Now when we're asked to solve, it means we need to find x, okay? And I'm going to start by putting in my solving lines, which are just lines to the left and right of the equal sign. And what we need to do is get x on its own on the left-hand side. Well, what's stopping x from being on its own? We've got this 12 here. Well, what's that 12 doing to the x? Well, it's timesing it by 12. So we need to do the opposite of that to get rid of it. What is the opposite of times 12? Divided by 12. Now these lines show us we've got to do the same to the left and right. So if I divide the left-hand side by 12, I have to divide the right-hand side by 12. So on the left-hand side, we just have the x, which is what we want. On the right-hand side, we do 36 divided by 12. How many 12s in 36? That would be 3. So our solution is x equals 3. To find a coordinate, what we can do is we can start in the middle, and we work out how far across we have to go. And here we have to go 2 across, so the x coordinate is 2. Then we find out how far upwards or downwards we have to go. And here we can go, well, we have to go 3 downwards. So that's going to be minus 3. So we first of all look at the x coordinate, the 2, then the y coordinate, minus 3, along the corridor, up, or in this case, down the stairs. We're going to start off with a dot at minus 13. And it says that x can be greater than minus 13, and greater is to the right of that. And it goes on forever, so we just put a little arrow saying it goes on forever. Last thing we do is check to see whether it's hollow or a filled in dot. Well, this cannot be equal to minus 13, so it remains a hollow dot. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100, to make it a multiplier. So the multiplier is 1.012. So we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which gives us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. The question asks us to find the bearing of A from B. That means we're at B and we're looking at the bearing of A. So bearings always start from north and go clockwise, so we're looking for this angle here. Now there's a few ways of doing this, a few different ways of doing it. The way I'm going to do it is I'm going to find this angle here, and the angle that we're given, the 35 degrees, and this angle are interior angles or co-interior or allied angles, because if we look, they make a beautiful C shape when they're connected, like so. So to work out this angle, what we can do is we can do 180 take away 35, and that would give us 145 degrees. And so this will be 145 degrees. And the method we use for that is that they are interior angles. And then to find the angle we're looking for, we can just do 360 take away the 145, which will give us 215 degrees. And the reason for that is that they are angles at a point. Angles at point add up to 360 degrees. So my answer will be 215. So we can see that the first four of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17. So 21 and 17 would be roughly there. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. Here we're given a triangle, and we're not actually given the values of each of the angles. We're given them in terms of x, but we know that they're going to add up to 180. So we're going to do the 20x plus the 2x plus the 23x, and we know that it's going to equal 180. And the reason is that its angles in a triangle add up to 180. Okay, let's get our tramlines in, because we've got algebra and we're solving here. We're going to put our tramlines in. Now on the left hand side we need to add these x terms together. So 2x plus 23x will be 25x, plus the 20 will be 45x. And what we're going to do to get x on its own, we're going to divide both sides by 45. So we're going to divide by 45 both sides, and we're going to end up with x equals 4. There are a number of different ways of working out this question. You can find out the amount of tissues per penny. You can work out the amount of, or the price of one tissue, or you can get all the amount of tissues into the same amount. I'm going to find out the price per one tissue. And we're going to start off with the 24. And what I'm going to do is I'm going to convert the money into pence, just to mean that we don't have as much decimal. And we're going to do 807. I'm going to divide by the 24 to find out the price of one tissue. So that is 33.625. And so I'm just going to round that to 33.63. I'm just going to round everything to 2 decimal places, which says in the question. Next one, we're going to do the 20 soft tissues. So this time I'm going to do 683 divided by 20. When I put that into the calculator, you get 34.15, so that's already 2 decimal places. And then finally we're going to do the 15 soft tissues. So we're going to do the 623 divided by 15 to find the price per tissue. It should be 41.533 blah blah blah, and rounded would be 41.53. So if you buy 15 tissues it will cost 41 pence. 20 tissues it will be 34 pence per tissue, but 24 tissues will be 33.63. So that's by far the cheapest. The best value is the 24 tissues box. Now there's such thing as buying in bulk. Generally, the more you buy of something, the cheaper it is. Don't rely on that. Both in the GCSE, both in the exam, and in real life. Sometimes in real life, if you buy more of an item, actually per tissue, sometimes it becomes more expensive, especially if there's a special offer on the smaller box. Okay, first of all, we need to work out what the interior angles would add up to. So the sum of the interior angles is equal to n minus 2 times 180. Now n is the amount of sides, but it says it has 5 sides, so it would be 5 take away 2, which is 3, and then times 180, which would be 540. So we know it will add up to 540. So all we need to do is get that 540 and take away all the angles that we know. So the 118, the 84, the 108, and the 151. And when you do that, you get the answer of 79. To find the area of a circle, we use the formula area equals pi r squared, or pi times r squared. We're given that the fact that the radius is 12, so it would be pi times 144. Type that into the calculator and you get 452.389 blah blah blah. And the question asks us to round it to 2 decimal places, so that would be 452.39. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. and so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19. And we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include a, s, v and u? That's got a t in it, that's got a t in it, so it's going to be this one here. So let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So we're asked to find angle BCE. And that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour, because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one, and the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got 2 of the 3 angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use 1 bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. We're going to start this question by writing down what we know. So the toy car is travelling at 17 meters per second initially. So the initial velocity or initial speed is 17 meters per second. It accelerates for 4 meters per second squared. So acceleration is going to be 4 meters per second squared, and it's for 12 meters. Now, displacement just means distance as a vector, so we're going to use displacement, and we use the s to show displacement, just to be confusing. So displacement is always the confusing one. And we're asked to find the final velocity. Now, the final velocity is shown with a v. So that's what we're looking for. So we're going to find out which of the formula we're going to use. Now notice we're not given the time, so all the formulas with t in them are not going to be useful. We're not looking for or are given the t. And it's going to be the last formula, the v squared equals u squared plus 2as. Okay, let's fill in what we know. Well, we're looking for v squared. Well, we're looking for v, so we'll leave that. And so it's going to be 17 squared plus 2 times 4 times 12. And then when you work that out on a calculator, that comes to 385. And we're going to do some quick solving here. And we're going to square root both sides to get rid of that squared. So we get v equals the square root of 385, which is 19.621, etc. And it wants it to 2 decimal places, so we're going to write down 19.62 meters per second. So in this question, we've got a right angle triangle, and we're asked for length BC, and we're given the other 2 lengths. It's going to be Pythagoras. And so for Pythagoras, I just label the sides A, B, and C, but C must be the one opposite the right angle. And Pythagoras says that a squared plus b squared is equal to c squared. We don't know a is squared, but we know what b is, which is 5.2, and we know c is 11. So when we do that, we get a squared plus 27.04 equals 121. And we just solve. So the first thing I'm going to do is take away the 27.04 from both sides. So we get a squared equals 93, 93.96. There we go. And to work out what a is, we just square root both sides. So it'd be a equals 9.693 blah blah blah. Asks us to do 2 decimal places, so we write 9.69. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we're just going to copy this out first of all. So we've got x equals y over 15. Now we're asked to make y the subject, which means we want y on its own. What's stopping y from being on its own? Well, it's divided by 15. That's what over means. It means divide. So how do we get rid of that divide by 15? Well, we do the inverse, or the opposite, which is times 15. So we go times both sides by 15. X times 15 is 15x, and it will get rid of this fraction here and just leave y. So y is 15x. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid, and we're going to do x minus 15 at the top, x minus 15 at the bottom, then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x, same again here, and then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. Factorising is the opposite of expanding. With expanding, we're multiplying out a bracket. With factorising, we're putting something in a bracket. So I'm going to start by just putting the bracket down. Now I need to ask myself, what number can I divide out of 3x squared and 5x? Well, there's not going to be a number I can divide out, but they both have at least an x. X squared obviously is x times x, and x is just on its own for the 5x. So we're going to divide out the x. So I need to ask myself, what times x is going to be 3x squared? Well, obviously 3x. And then we ask ourselves, what times x is 5x? Well, that's just going to be 5. And if you were to expand that set of brackets, you will get 3x squared plus 5x. So we know it's the correct one. And so our answer will be x brackets 3x plus 5. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%, so we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100, so we're just going to divide that by 100, and this will give us the decimal or the multiplier. So the multiplier is 1.016, and so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400, that's our original amount, and to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.0167 times. Or, easier way of doing it is 1.016 to the power of 7. When we do that, we get 2682.052 blah blah blah, and because it's money we round to the nearest pence, so 2682.05. There are two shapes we need to find the volume of. There's this cylinder here and this hemisphere here. So we might as well start with this cylinder. And the formula for the volume is pi times r squared times height. So it's the radius is 9, so 9 squared times the height, which is 30. And when we work that out, we get 7,634.070, blah, blah, blah. Next is the hemisphere. To find the volume of the hemisphere, well, the volume of a sphere is 4/3 times pi times r cubed. But because it's a hemisphere, we just times that by a half. So it's half times 4/3 times pi times r, which is the radius, which is 9 cubed. And that gives us 1526.814, blah, blah, blah. And so the total volume is 7,634.070, blah, 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 plus the 1,526.814, blah, 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 which equals 9,160.884, blah, blah, blah. It says it wants it two decimal places, so when we round that, we get 9,160.88. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3/5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3/5 times 2/4. And I realise I could cancel 2/4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2/5 times 3/4. So 2/5 times 3/4, 3/4. That would be 6/20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6/20 plus 6/20. And this is the probability of different. Which will be 12/20. Now 12/20 will cancel to 3/5 or 3/5. To find an error interval, I first of all start with drawing a number line. And the box is 130 centimeters, so we're going to put that in the middle when rounded. and its thickness is 10 centimeters. So what I'm going to do is I'm going to take away 10 centimeters, which would be what, 120, and add 10 centimeters. So the number line will be going up in tens because it's rounded to the nearest 10. To find the lower bound, what I do is I find the halfway point here, and to find the upper bound, the maximum it can be, I find the midway point here. So the midway point here would be 125, halfway between 120 and 130, and the midway point here will be 135, which is halfway between 130 and 140. So those will be our lower and upper bounds, the minimum and maximum it could have been before rounding. We're representing this with a H. And what we're going to do is we're going to show this as inequalities. Whenever you do an error interval, you show it with inequalities. So it can be 125, so we're going to put a line underneath the inequality there, but it can't be 135. It can be anything up until 135, because if it was 135, it would round to 140. We're going to start by drawing a table of values. We draw the table of values because we've got a curve here, and with a curve you need quite a lot of coordinates to make sure you get the curve right. Now ideally I'd go up in halves, but so that I'm not just sitting here writing numbers, I'm going to go up in ones on this one. I'm going to leave a space there though, and we'll see why in a second. So what I'm going to do is type these into a calculator. I'm going to type in 0.5 times brackets minus 2 close brackets cubed plus 8 into the calculator, and that gives me the answer of 4. I do the same with minus 1, that gives me 7.5. 0 gives me 8. 1 gives me 8.5. 2 will give me 12. 3 will give me 21.5. The reason I've left a space there is this axis doesn't go up to 21.5. So what I'm going to do is just do 2.5 to see if it goes up to that, and that should be 15.8125. So that's actually quite useful because that shows that it's not quite 16. So we were aiming for roughly where 16 is. So next thing we do is plot these coordinates. So 2 would be at 4, minus 1 is 7.5, which we can't be perfectly accurate for, but it's roughly there. Then 0 is 8, then 1 is 8.5, roughly there. 2 is 12, and then 2.5 is just below that 16. So it's almost at 16. Then the next thing we do is just join it up with a nice smooth curve. It's sometimes helpful if you turn your paper sideways. Obviously I can't do it when I'm on this computer. But you want to just keep drawing and don't lift your pen off at all. Just go with the points. And you want to avoid things like feathering, which is like that, where you do that kind of thing. And you kind of want to avoid, or you want to make sure you go through the coordinates. And you just make it a nice smooth curve. The exam is very forgiving when it comes to curves. They know that not everyone's got the steadiest of hands. So as long as yours goes through the points and doesn't have like gaps in it or feathering or anything like that, and it's just one continuous smooth line, then you'll get the marks. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC, and I'm going to do that using trigonometry. So we've got the 90 degrees there, so it will be, well, we'll start by labelling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29, and we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that on the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79, and that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. To find the volume of a cone, we use a simple formula, which is 1/3 times pi times r squared times h. The r is the radius, so that's the 5 squared, times, and h is the perpendicular height, the one at right angles, so that is 10. When you work that out on a calculator, you get 261.799 blah blah blah. And when we round that to two decimal places, we get 261.80. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is minus 1. So our answer is 10 minus 1. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.